In this video, we present the visualization by demonstration paradigm with the help of a prototype system. A system which adopts this paradigm allows users to provide visual demonstrations of incremental changes to the visual representation. The system interprets these changes and automatically recommends visual transformations. Visualization by demonstration supports 4 different types of transformations: visual representation transformations, data mapping transformations, axis transformations, and view specification transformations. Visual representation transformations. For example, we can stack 2 or more data points vertically in a scatter plot to indicate interest in switching to a vertical bar chart. Data mapping transformations. For example, we can change the color of some data points to red to convey interest in mapping color to an attribute. Axis transformations. For example, in a scatter plot, we can position 1 or more glyphs at certain locations on the view. This would switch the attributes on the axes to the values where the glyphs appear closest to their new positions. And view specification transformations. For example, we can indicate an interest in sorting a bar chart by dragging the tallest bar to the extreme left or right position. To illustrate the feasibility of the visualization by demonstration paradigm, we developed a prototype system. We present the tool with the help of a use case. Imagine Bob is interested in buying a car. He decides to use our tool to explore his options. Upon loading the data, the tool shows each car as a green circle on the think board. Bob likes the Honda Civic Hybrid that his friend John used to drive. At the same time, he dislikes John's new car, a Toyota Land Cruiser. Bob wants to leverage this preference, so he starts the data exploration process by searching for both of these cars in the search box. He decides to color Honda Civic blue and Land Cruiser red. The system interprets these actions and recommends data attributes for mapping to the color of all cars. Before committing to a mapping, Bob previews the options by hovering on the brush icons. Finally, Bob selects the number of cylinders attribute by double-clicking on the icon. Bob observes that the car that he dislikes has 8 cylinders, so he's curious to know how many other cars have 8 cylinders. To answer this question, he stacks a few cars with 8 cylinders on the top of each other. The system interprets the stack and recommends a collection of bar charts. All the bar charts have the count of cars on the y-axis, but differ in the data attribute used for the x-axis. In this case, Bob decides to stack cars vertically based on the cylinder attribute. He notices that most of the cars are 4-cylinder, while only a few are 8-cylinder. To draw a more detailed comparison of the 4-cylinder cars, Bob switches to a scatter plot by dragging a car out of the bar, thus creating a visual layout that resembles a scatter plot. To differentiate between the 4-cylinder cars, Bob decides to make the size of the Honda Civic Hybrid car that he likes bigger. Upon doing this, the system interprets these actions and recommends data attributes for mapping to the size of all cars. Before committing to a mapping, Bob previews the options by hovering on the expanded icons. Finally, Bob assigns size to highway mileage per gallon.